Due to growing product stickiness, a hard candy manufacturing startup is unable to meet client demand. Before being stored, the product is put through several quality checks. The quality control team determined that the problem might be related to storage after noting that it had nothing to do with manufacturing. The team has brainstormed and listed the potential causes for increased product stickiness during manufacturing and storage phases to determine the best method to prevent stickiness and recover from loss. So let's take a look at the case here. The problem setting is increased stickiness of hard candy during storage. So our product, hard candy, is made of sucrose, corn syrup, and water. So what exactly in hard candy has contributed to this increased stickiness? Hard candy is processed in a manner that the hard candy is converted to glassy amorphous state below its glass transition temperature. In this glassy state, the system is kinetically stable and molecular mobility is severely constrained. This means that temporary stability of hard candy is attributed to the glass transition temperature. So let's take a look at what are those parameters affecting glass transition temperature. The first important parameter affecting glass transition temperature of a product is your moisture content. It can be during processing or during storage. Water is one of the most fundamental ingredient in our product, but it has the greatest impact on quality parameters as well. Water serves as a plasticizer in foods. The presence of plasticizer improves food softness, flexibility, and extensibility. So, glass transition temperature is inversely proportional to plasticizing effect, which means more the amount of water present in your food product, lower is the glass transition temperature gonna be. So when you add plasticizer like water to your product, what it does is it reduces the viscosity of your food system. Just to give you an idea, if you look at this diagrammatic representation, you can see in glassy state, your food product has high viscosity and low molecular mobility. When you add water, which is a plasticizer, the molecular mobility becomes medium and the product enters a rubbery phase. On further addition of water, there is high molecular mobility, which implies your food product is in solution state. So, from this, you can understand small fluctuations in volume of water in the system can have a huge impact on the glass transition temperature. This means that modest alterations in water can also have a significant impact on food stability. The second important parameter is temperature. So, when we are discussing molecular mobility theory, one vital assumption that we make is that there is no mobility at molecular level, even though we have mobility at atomic level through rotations and vibrations. Therefore, we can say that when food is present in a state other than glassy state, like let's say rubbery state or solution state, molecular mobility is higher than in glassy state. But how is this higher molecular mobility quantified? Mobility is quantified using something called relaxation time, represented by Greek letter tau. So this relaxation time is nothing but it is how much time is required for the food system to return to its equilibrium state after it has been disturbed. So if you look at this temperature dependency of our system or hard candy, it can be in glassy state, it can be defined using Arrhenius equation. If you know the activation energy and glass temperature, you can get a value for tau. In rubbery state, we make use of another equation, which is William Landau very equation that is given here, you can see that eta T and eta Tg, they are viscosities at temperature T and viscosity at glass transition temperature. C1G and C2G, they are universal constants. And then you have temperature T and Tg, which is your glass transition temperature. Third is type of solute. Suppose we have two systems with identical water content, but one is rich in sugar and the other one is rich in polysaccharide. The one which has sugar will have considerably lower glass transition temperature than the one with complex polysaccharide. And why is this the case? Because glass transition temperature is directly proportional to the molecular weight. Then, apart from water, food can have several other tiny molecules like ethanol and glycerol, which can also act as plasticizers in food system. Finally, you have solute concentration. So the impact of solute is much more pronounced when your food product has lower moisture content. Why? Because if moisture content is present, it is going to be the dominant factor determining what the glass transition temperature should be due to its plasticizing effect. Hard candies, okay, like our product, hard candy, it is made of sucrose, corn syrup, and water. Suppose our hard candy is having higher concentration of sucrose, then it is much prone to a process called graining during its storage. If it has higher concentration of corn syrup, then it is more susceptible to stickiness during storage, just like our product. Why is this the case? Because corn syrup has innate ability to absorb moisture. So even slight variation in temperature or relative humidity in the storage room can have an impact on the texture and quality of your product. Thank you for staying with me through the video. In case you have any queries, please feel free to put them in the comment section and I'll get back at the earliest.